Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction and a commentary to one post, a very interesting post by one of our favorite people here in terms of imparting wisdom about software development, GeePaw Hill, or GeePaw Hill. And the post is about something that he called RORA, which means runs once, run away. So basically, that feeling that you have as a developer that you made something work and then you just want to run away and don't see it again. But I like that he goes into more detail and talks about RORA process, RORA style, RORA product, RORA code, and so on. Now I'm going to skip to the point where he starts talking about the things. Two quick ways to think about this. We have a word to describe systems that stop changing. That word is dead. Change is a good thing. When people want us to change X, it is because A, they see value in X, and B, they want to keep using X. This is one of the things that I have faced in the beginning of my career. The assumption was that we would write code and forget about it, kind of stop changing it. And whenever we were about to change it, it was rework or something bad. When in reality, I have come to understand later on that any application that's being used will change. People will ask things from it. So when people ask for changes, it's because they are actually using the app and they want more features. And I think today it's pretty clear. Maybe there are some pockets where this is not very clear, or maybe for junior programmers just out of university, but know that successful products, they keep changing. On to the second order, a little closer to the concrete, but still not all the way down to the nuts and bolts. First, the system does not express itself clearly to humans. The humans include the users, the deciders, the operators, the marketers, and or the makers. In any system featuring machines, artifacts, procedures, and humans, the humans dominate every production function. When we fail to emphasize meaning adequately, we produce systems that are very often dead on arrival with effectiveness, support, and trust. This is a very important thing. Another thing that I keep hearing is that it's very controversial. One of the most controversial statements that I made was that programming is a profoundly humanistic activity. And look, it really is, because the application that you are building needs to include this meaning. And meaning is defined by the people who are interacting with it. So it's very interesting to see that, meaning expressed to the users. How do you express meaning to the user? Typically through the user experience, the user interface. How do you express meaning to the deciders? Goals, and so on for your product. For the operators, operations. You give them enough information, architecture diagrams and so on. The marketers, what is the product about, and so on. And the makers, this is where we spend most of our lives as developers. Second, the system is not validated or verified in any systematic, in-depth, or in-practice fashion. It is assumed to be correct because the logic of it seems coherent, and it is assumed that if it is correct, it is also valuable. It is not demonstrated to be correct, and even if correct, it is not demonstrated to be valuable. It is, not to put a finer point on it, a Platonic system that will work very well indeed in the lands of Plato's forms. This reminds me of an old joke with a bunch of scientists looking at at a race between, I think it was the hare and the turtle or something like that. And one of them saying, you know, I can make the turtle win if we would be working in an universe where everything is a perfect cube or a perfect sphere. And of course, it's not. So these are assumptions that we make related to products. And as you can see, validation does not refer only to the fact that it works or that it has logic, but also that it is valuable. So testing value is a very important part of product development. And there are a lot of techniques for doing that. I have gone into in depth with this topic since we have an Agile product management course, which proved to be very useful for people switching to product management and thinking in this way. Third, the system assumes that its value is vested solely in its endpoint artifact. In fact, much of the value of a system comes from its status as a work in progress for those who make, those who manage, and those who consume. This might sound like a reiteration of the third order point and change happens, but it's more than that. Progressive enhancement and elaboration as a trend is the single most powerful attractant for makers, managers, and consumers alike. That is value. This is an interesting point. I think psychologically, he's right, in the sense that if we imagine if you add a new big feature every 2 years, compared to adding small, high-impact features every month. Which one would make you feel better? You as a developer, managers, end users. Now, it depends a lot on the users, but on the area, on the level of managers and developers, I think it's more likely that you'll be happier if you add things and you see the product improving. Now, the trap here is that you are doing busy work and you just implement a list of features that you decided in the beginning that would be a good idea, instead of listening to the feedback and investing the minimum amount possible into the high value, high impact features. So you have to be careful here what you're doing, and there's a continuous struggle to get there. You are never quite at the point where you are implementing the best, the most impact features in the fastest way possible. There's always something more to learn about that. And that's an asymptotic goal, but trending towards it is what makes these jobs very interesting. Okay, he had a few things. All right. We come to the first order RORA, the nitty-gritty, the concrete factors that predict RORA outcomes. There are a bunch of these and they somehow overlap. No one of them is enough to ruin a project generally, but if even 2 or 3 of them are present, RORA is my diagnosis. Let's see which one are them. Number 1, weak or non-existent testing, plenty of variance. A. Testing is performed primarily by manually invoking the whole program on a curated dataset. B. Testing is automated by slow outside the developer's box and is really the same as the above, only with a script instead of a human doing the work. C. Tests are written primarily after the code is written. D. Tests are not written by the developers. E. Tests are not run by the developers. F. Tests only test success paths. So all of these discuss about the scenes or the lacks of testing, where again in the beginning of my career it was normal to have a separate department that would do testing, and you'd call them at the end to test everything that you have implemented in the meantime, and typically they didn't have enough time, enough people, testing was always delayed. You would end up with a product filled with bugs that you would ship and then negotiate the bugs with the client. Basically negotiate who would pay for them. But we are not there now. Where we are is at a point where we can write tests, developers can write tests first, and writing tests first is probably one of the most controversial things nowadays in this industry. Many people still don't understand why it's useful to write tests first. But the thing is, writing tests first allow you to clarify what the goal for your code is. And that is very, very important, because in that way, you can also write the smallest amount of code possible. And if you keep refactoring, which I guess will be discussed later on. There's also a matter of responsibility. When, let's say I would get a task in the beginning of my career, and then I would implement that task and then forget about it. And 6 months later, or 1 year later, we get a bug in the code related to that task. And if I am lucky, air quotes, then somebody else will have to fix the bug and struggle with my code. And because of this, there was no responsibility chain, right? My responsibility stopped at implementing the task, and then I could forget about it. And that's a big problem, because fixing bugs is good feedback for developers. If we find bugs and if we fix them, we learn how to avoid writing bugs in the first place, which is a good thing both for the product, for the business, but also for us. We feel better when we don't introduce bugs. So this is another reason why tests are so useful. If you have tests, you can find bugs very quickly, you can fix them, you forget about those. Of course, some bugs will escape, but ideally what you'd have is more complex bugs that escape, weird things that a tester with a good imagination will find. So this is why it's very important to test everything, both success and unhappy paths. Run tests, write tests before writing the code, and run the tests. Make sure they run on your machine, and then, of course, you can go through the different levels of testing. Okay, still more. At the same point, weak or non-existent testing, plenty of variants. We are at point G. Tests are slow. H, large-scale tests operating against all or most of a program are overvalued. I, failing or frequency tests are ignored. J, tests containing no validation beyond it ran. K, test quality is evaluated solely by code coverage. L, tests are hard to write. M, tests are not added to cover the hole when bugs are shipped. And tests don't clearly describe what they are testing. Yeah, so a lot of things here. And I think we touched on a few of them. But yeah, basically you need to have tests that make sense, that are named appropriately, clearly describe what they are testing through their names. Make it easy to write tests, which means that your design is to accommodate testing. This was a whole discussion when we started adopting testing. Is it okay to change the design so that tests are possible? And it's a matter of value. Yeah, it's okay because it's valuable to have tests in most situations. Okay, maybe there are a few like very high performance requiring applications, like high performance a high frequency trading. Okay, in that case, maybe the most important part is to make things as fast as possible, because the difference, a millisecond will count for maybe millions of dollars in terms of value. So I can understand in that case, but if you are not at that level, you most likely need tests. And even at that level, you might need tests, only maybe you need to be a bit smarter on how you write it so that you keep the performance as well. But yeah, adapt your design so that it's testable. Absolutely. Tests are slow. So you need fast tests that are failing or flickery tests are ignored. You need fast tests that are repeatable. When you rerun them, you get the same results. They don't depend on external factors. So yeah, should be easy to write tests. And code coverage is not the only measure of test quality. Tests should be very clear, very small. And then you have another interesting point here. Tests are not added to cover the hole when bugs are shipped. So when you get a bug, the first thing you should do, write a test that reproduces the bug, then fix the bug, then the test passes, and with this, you keep the test as a reminder of the mistakes you've made and as a way to prevent it from happening again. Okay, number 2, we are moving to another level. Code is developed primarily by individuals in isolation. This is a huge factor in undermining the meaning of the code. A. Code is asynchronously reviewed. B. Code is kept on branches. He skipped C. D. Shipped bugs are not workshopped. E. Teams neither pair nor mob nor swarm. F. Performance and productivity metrics are applied to individuals, not teams. So here I have a few comments. I know that there are some trunk-based development absolutists out there, people who believe that the only way you can write good code is to use trunk-based development, which, in case you don't know, is to commit everything on trunk. And I've said again and again that this has costs. It's not something that is 100% the best way to solve this problem with continuous delivery. So I am okay with code being kept on branches. This is where I disagree with GeePaw, but I believe that branches need to be very short-lived, so in terms of maybe 2 days, 3 days. If you have a branch, and I mean feature branches, okay, maybe you have a main branch, maybe you have a kind of integration branch, but feature branches need to be very, very short-lived. And that's it. Because the problem here is not necessarily that the code is kept on branches, it's the feedback cycle. How long until things get integrated and you realize that things are okay or not, all the way through to production. But honestly, there are other ways of dealing with that. So one particular technique is, if you have your feature branch, you should integrate the upper stream branch into your branch at least daily, if not more than daily. So, and this is a technique that works very well. It allows you to do continuous delivery without having to deal with feature toggles and other ugly stuff like that. So it's up to you which one you choose. Like both are good solutions, but you'll need to pick one. The key here is don't keep long-lived branches. Long-lived branches are bad. Code is asynchronously reviewed. Here I also have a few issues. I know again that ideally you'd have ensembles or pairs. Honestly, I think there should be more levels of review. So for example, I'm all for having, even if you have a pair or an ensemble building part of the product, building a feature, I still think we need somebody else to look in terms of architecture, in terms of security, in terms of other things. Because the reality, the psychological reality is that people hit a common ground, and in social environments that tend to use the same patterns, and sometimes those patterns are good, but sometimes they might prove not as good. So then what you need to do is to have also an outside view on their work. So I don't think that asynchronous reviewing is the problem. The problem is blocking, so increasing the feedback cycle by blocking things due to reviews. That is a problem. So ideally you do pair programming or ensembles, and then you'd get out of these features that you can already move to next stages, but at the same time asynchronously review for other things, security, performance, and so on. Number 3, code is poorly factors for makers to work with. And here we have long methods abound. Yeah, use short methods. Short methods are great. They are easier to understand, easier to name. They have a single responsibility. They can be composed better. Only good things. The downsides of short methods are that sometimes it's more difficult to understand what is happening because you need to go through different levels of abstraction to understand the details. But most of the times you don't need to understand the details. You just need to trust that this thing works. It does what it's supposed to do. And even if you don't trust it, you can make a small experiment, because if you're using test-driven development, you write your test first, you'll call that method, existent method, see if it solves your problem or not, and you'll learn based on that. Is that the one or it's not? Or if you're working in a pair or in an ensemble, other people will know most likely what to use and what not to use. So you are using the knowledge of other people's in the team. And I like the next one. B, slalom code is present where indentation goes to 4, 5, or even more levels in a method. I like that he calls it slalom code. I haven't heard this before. It's pretty funny. Yeah, you shouldn't have a lot of indentation levels. He says 4, 5. I would stick to maximum 2. Because that's where you have methods that are easy to understand. If you go further than 2, you start getting murky. The name C, the names of things, classes, methods, parameters, variables are considered unimportant. Abbreviations, elided vowels, one-letter names are common. Names are the most important part of your code. Everything that you are using in your code has been named by a developer. So think about it when you are naming things. Make sure you name things properly. in a way that other people understand in 6 months, that you understand in 6 months. Explicit entities and relationships in the problem domain are not directly represented in the code. Yeah, this is a more subtle one, but it is. So in order to do that, first you need to understand the domain. And once you understand the domain, then it's easier to make this happen. Okay, and it continues. E, native type and operations are freely mixed with advanced domain types and operations. Okay, I guess it's a level of abstraction problem here, although with my C++ backgrounds, this is okay many times, but right. The only aggregates F, the only aggregates that are used are the native collection classes. You can implement your own aggregates. Do that. G, get and set are commonplace and can mean absolutely anything. Yeah, try to avoid get and set. They don't give you enough information as a name. What does get mean? What does set mean? H, immutability and mutability are not chosen and explicit, but incidental and implicit. Whenever you can, choose immutability. Immutable code is much easier to understand, much easier to test, much easier to predict than mutable code. Now, there are some reasons for using mutable code. Some of them are related to performance, particularly in programming languages that don't support immutability by default. But other than, and when you are dealing with I/O, but other than that, immutable code rules. I/O and other awkward collaborators are fully intermingled with domain logic. And J, third-party libraries are not isolated from domain logic, but spread throughout it. Yeah. So the domain logic should be very clear. There's one pattern called screaming architecture, where you organize your code so that the domain logic comes first. When you open your project, you see the domain logic. Maybe you've heard about clean architecture by Robert C. Martin, or hexagonal architectures, or ports and adapters. These are all patterns that isolate the domain logic from third party. And my favorite ones are immutable core, and I never remember. So it's immutable core and procedural shell, something like that. Basically, you have the domain model, you define it, it is separate from everything else. You implement it using immutable code and pure functions. And the outer edges of your system are the ones that collaborate with third-party libraries, with APIs, with I/O, system primitives, and so on, through some kind of adapters or ports or facades or whatever. But fundamentally, what this means is that you can test your domain logic completely separate from the delivery mechanism. You can use the same domain logic to implement a command line application, a web application, a mobile application, an API, and so on. So if you think about your domain logic as kind of a library that you can deploy and connect with other third parties or with other I/O devices and so on, this is one of the best way of organizing the architecture of your product. Okay, 4. The design does not account for failure paths on ordinary problems. A, does not validate user input before trying to operate on it, and it does not give informative feedback on any problems. B, it shows users stack traces for problems it knows perfectly well are common and easy to detect in advance. C, it assumes its upstream suppliers are always up even when they are known to fail on a regular basis, and again, it does not inform users when they are not. Yeah, these remind me about my favorite definition that I came up with for software architecture, which is software architecture is when code meets the real world. You have your ideal protected world in where you can write your code, write your tests, make everything work perfectly, but then you need to place it in the real world. And in the real world, there are a few things that happen. One of them is computers fail, hard drives get full, third-party APIs fail, they go down, and so on. So then, and there are people who want to steal your data or to do bad things to your code, and so on. So even if you have a zero bug product that is 100% covered by tests, you will still have some issues when going into production. And you need to take into account the users, what they want, what they understand, and so on. So validating their input. By the way, users will introduce all kinds of weird things. You need to be prepared to check them. And you need to be prepared to give nice feedback to them because they are people and we want to help them, and so on. And then in terms of third parties, you need to have things like circuit breakers that allow you to have good answers or nice answers even when the suppliers are not up. Okay, then D, it raises context-less native exception instead of context-specific domain exception. This is a very important part of good design. You need to figure out what are domain-specific exceptions that have meaning not only for your users but also for your code. For example, if you have a certain if you are calling an external API, what can you do with an exception when the external API doesn't answer? Is the exception because they have changed the API and you are calling with the wrong parameters? Is it because the service is down? Is it because of other things? You need to be prepared for those things and treat them. And the best way to do that is to have your own exceptions that encapsulate this logic in the name, fundamentally. Most likely, because exceptions don't do much. But the exception names will give you a lot of information and you can catch that exception based on type and do something with it. Now the default thing will be to log and report somehow. Maybe show it to the user in terms of in certain situations, but for other ones, it's you need to be able to react as well. So this is why it's very important to have context-specific domain exceptions. E, it makes grossly incorrect assumptions about valid and invalid data. See the magnificent curated collection of falsehood programmers believe here. We touched on this before. I think we have another video on falsehoods programmers believe. We did a bunch of videos on time zones and date and time issues. By the way, next year, public service reminder, next year is a leap year, so prepare your code for 29th of February. F, it does not start by validating its configuration. Okay, that's an interesting thing. I think that makes sense. I've seen it. I haven't seen it enough, validating its own configuration, but configuration is an input for your program as well. So you should definitely validate it and never trust it. Well, trust it a bit, but not that much. Okay, that's it for now. I'm reading his last tooth. Okay, that's it from now. Hope this gives you some sense of what I'm talking about when I say RORA. RORA code is anti-change, anti-meaning, and anti-resilient. Please regard this as a first draft. I didn't say it all and I didn't say it very well. I'll try again, fail again, and hopefully fail better sometime in the future. Yeah, very interesting. I like this idea of RORA. So RORA stands for runs once, run away. If you make it run, just run away. And I like the focus on people. Always remember that you are working for people and with people. Even when we'll have AI, we'll still work for people and with people. And I also like some of the things that he said, like slalom code and other things like that. Slalom code, long methods. Yeah. So that's it for today. I found this very, very interesting. I like GeePaw Hill's posts a lot. He writes about various things that he notices. He's very observant and he's very thoughtful about these things, which I really enjoy. And even if we don't agree on all things, like I don't fully buy into the trunk-based development thing, and I don't fully buy into the bad things about asynchronous reviews. I love synchronous reviews more, of course. I mean, going back to asynchronous reviews, the best way to do reviews is actually to sit down with the programmers that wrote the code. And maybe that's what we should have talked about. It's good to sit down with the programmers instead of passing comments back and forth. That's not the best way of doing reviews. But we have another video on code reviews, so maybe you'll find more useful information there. Anyway, that's it for me today. Thank you kindly for the views. Thank you so much, because we've passed 600 subscribers. So it's a great thing for this channel. And we are growing slowly and steadily. I like that. I don't plan to push this channel a lot. It's just for people like you who find value in it, who come back to watch these interesting videos, and who engage with the community by writing comments. So please leave us a comment. We love comments, and I will keep answering them as soon as I can. Every 1-2 weeks, I'm going through the comments, answering, and hopefully start interesting conversations. What do you think about RORA? Have you seen this before? What do you think about these symptoms? What are the solutions that you found to these symptoms? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.